Welcome back, chemistry fans. Today, we are going to work on our on our quiz dealing with acids and bases. So let's jump right in and see if we can show you some solutions to some of these questions here. So you can fix your mistakes if you made any. If you didn't make any, not sure why you're on video, but let's go anyway. Okay, so all of these were multiple choice except for the last one. On number one, all of the following are acids containing chlorine. Which is the weakest acid? Okay. So what we have to know is that there is a salmon-colored list that was provided to you, and it has all of the strong acids. So by definition, chlorate, perchlorate, and hydrochloric acid are all strong. So by default, the only one that is not on that list is your correct answer. So that is your only weak acid on the list. All right, number two, which of the following would have the highest pH? The only one on here that is a true acid is the one that has OH in it, and so that would make it the strongest of the the strongest of the bases that are listed here, and it's the only one then that would make the pH go way high. So you just had to recognize OH as being a base. Okay, following. So we need to label these. We got to find our conjugate pairs. So this is a conjugate pair, and these are conjugate pairs. So we have to match up what they are doing. So acids give away H's. So here's an acid that's giving away its base. So that means that this is now a conjugate base on the other side. And then so by default, then if that's the acid, well, then this is a base and this is my conjugate acid. So now we're just matching up to figure out which one is the correct label. So HCO3 is an acid, that is correct. And CO3 is the conjugate base. Well, there's the first one and it matches. Let's just double check. NH3 is an acid. That did not work out. HCO3 is an acid. That is correct. And a conjugate base. And I'm sorry, and NH4 is the conjugate base. That is not correct, that portion. NH3 is the acid. That is not correct. So there is truth to what we, proof that we just got the correct answer on the first guess there. All right, moving on to number 4. And in question number 4, we are going to figure out which one of the following will have a pH of, I believe it says 3. Yeah, a pH of 3. So of these, when you put it into negative log of the concentration, the hydrogen ion concentration, if you were to plug those values in, both of those would give you 3s. Both of these would give you a very odd, let's see, what would we get? We would get negative 0.4 on these. So those are both out. Now, which one of these is able to use the actual formula is only this choice here. I'm sorry, is this choice here, because it's the only one on the strong acid list. The H2S is actually a weak acid, so we're not allowed to use straight pH. We would have to go through a Ka value, which is what you're going to have to do on question number 8. All right, utilizing this formula here, we're going to take 4,100 times the concentration of the acid, 6.8 times 10 to the negative 3 equals 250 times the concentration of the base, which is what we're looking for. Simple substitution. So 6.8 e to the negative 3 divided by 250. And what you get is 0.11. Very, very simple math. So just do some algebra and you'll come up correctly with this one. Again, this one, not too terribly challenging as long as you have your formula, 6.5 times 10 to the negative 3. The formula is negative log of the hydrogen ion concentration. Well, the reality is this is an OH. So we're actually solving for the hydroxide ion concentration. So we're going to have to fix that by subtracting by 14 in the end. But let's first plug in negative log of 6.5 times 10 to the negative 3, and we get 2.19, but then we're going to subtract 14 from that, and that will turn it into the pH, which is 11.8. Again, OH makes it a base, so we actually solve for POH. We need to then convert that by turning it into pH. All right, which one of these is a strong acid? Strong acid will be indicated because it will have most of the curve below 7. So the only one that fits that is here. This one smack dab, it's even on top and bottom. This one even on top and bottom. This one has a majority above, so that would be a strong base. This is my only strong acid because majority is below the 7. All right, and last question. So on this one, what we are going to have to do is utilize our Ka value to try and figure out what the correct pH is. So how we do this is we're going to first utilize Ka as equal to products over reactants. Now, in this case, my product is this 0.75, I'm sorry, my reactant is the 0.75. I don't have a product value given to me. What I do have is a Ka value, 1.12 times 10 to the negative 10 equals the products over the reactants of 0.75. So I could simplify this real quick. So 1.12 times 10 to the negative 10 times 0.75 is equal to 8.4 times 10 to the negative 11th. Now, what are my products? Well, there are 2 products listed here, but they're going to split into equal ratio, a 1-to-1 ratio. So if I wanted to symbolize them, they would both be X's. Well, in the Ka setup, if I have 2 X's on top, that just means they're being multiplied. So this actually ends up being X squared. So to solve for one of the X's, we're going to need to take the square root of both sides. So I will take the square root of that 8.4 times 10 to the negative 11, and I will get 9.16 times 10 to the negative 6. Now that is just my hydrogen ion concentration. So now I have to take that and put it into my pH is equal to negative log of the hydrogen ion concentration. So I'm going to plug that in here. So I'm going to do negative log of that value we just got. So we'll do negative log of this. And what I end up with is 5.03 or 04. And it's close enough. Now, both of your problems solve the exact same way, even though the values are just slightly different. The setup is solving for them is exactly the same on both. All right. Thank you very much for your time. I will talk with you again soon. Farewell. Bye-bye.